This is Chapter 8, Univariate Data Analysis, Section A. So before we begin, I just want to say that this specific chapter is very heavy in terminology, so it's really important that you understand all of the definitions that are provided in blue and that you have a running document that has all of these definitions. So you can either follow along with me in the videos or you can use your textbook. This starts on page 171, which I'll just write here in the top corner so that you remember, page 171. And it would be helpful for you to pause the video as it goes along to get down all of this information. So if we start off by talking about statistics, we want to think about what is it? So it's the art of solving problems and answering questions by collecting and analyzing data. So if you think about what we use statistics for, what involves statistics, we think about, well, lots of sports teams would collect stats. The UN would collect stats about different countries. One thing that is going on right now in our world is that the World Health Organization, or the WHO, is collecting lots of information about this huge outbreak of COVID-19. So these are all platforms for people that need to use statistics to be able to understand what's going on in their sports team, in the world around them, in health specifically. So much like when we're solving word problems and there's steps to it, there's a statistical method, and it's the process of investigation. So if we look at here, there's 6 steps. So the first step is examining a problem which may be solved using data and posing the correct questions. And then our second step would be going around and collecting data, and sometimes that's through an interview, sometimes that's through online surveys. There's various forms of doing that, so collecting data. So next we have step 3, which might be, which is organizing the data, which could be putting the data in a specific order. Maybe it needs to be divided categorically. Did you inquire based on age groups? Do you need to divide it into just different categories? Step 4 would be summarizing and displaying the data. So that's when we look at the different types of graphs. So previously in middle school, you would have looked at bar graphs and pie charts and line graphs. So that would be how we would display our data. Step 5 is really important. So this is where we analyze the data. And you need to make some form of a conclusion about the problem that you may have been assessing. So what do you notice from this data? And then finally, it would be writing a report. So next we're going to move into, there's a couple different types of variables that we're going to focus on. So the first one that we commonly deal with would be a categorical variable. And this is one which describes a particular quality or characteristic. So it can be divided into categories. So some examples of this would be, well, think about how you get to school. Oh, that's not what I want. Let me erase that. So if we think about getting to school or modes of transportation, well, in a city you might think about a bus or a train or a car, or maybe you walk, take your bike. So this would be different categories, right? Bus, train, car, walk. These are all the different categories of modes of getting to school. Another topic could be color of eyes. So the categories here would be blue, brown, green, hazel, etc. So these would all be the different categories part of this topic, color of eyes. The next type of variable that we have is a quantitative variable. And this is one in which there's a numerical value. So that's the really key part of quantitative. There's a numerical value. And it's often called a numerical variable. And this information is collected as numerical data. Okay. And there's two different types of quantitative variables. So there is discrete variables that take exact numbers and is often a result of counting. So if we think about different examples of a quantitative discrete, that would be thinking about, well, if you counted the number of people in our class, let's say in grade 9 total, well, we would say 1, 2, 3 if we lined them all up, and so on. Another thing would be thinking about the scores on a test. So if a test was out of 25, the scores could be 1, 7, 12, 13, 21, 24, 25. So these are all collected by counting something. So those are quantitative discrete variables. On the flip side of this, there is quantitative continuous variables. And these take numerical values within continuous and certain ranges, and it's usually a result of measuring. So if we think about measuring the heights of people in grade 9, so we might say that people are between 140 centimeters and 160 centimeters in all of grade 9. Another thing we could think about would be weight. So everyone weighs between 130 pounds to 170 pounds. Okay, so do we notice that there's a difference between these ranges that have been taken through measurement versus something that we can distinctly count? Now let's talk about a census. So first of all, there are two types of ways of data collection, and one is called a census and one is called a sample. So we need to understand the difference between the two. So a census is a method which involves collecting data about every individual in a whole population. So here's my little fun fact. So Canada does a census, I believe it's every 7 or 10 years, I can't remember. But in this census, they do try to collect the information from every single individual in Canada. And when I graduated from university, I worked for the latest census in Canada, and I had to go door to door to different people and ask them information and have them fill out an entire booklet. And so you can imagine how difficult it would be to find information on every single person in Canada, as many as we could. So that's a census. So it's about the whole population, and that's what's key there. Then we look at a sample. So a sample would be collecting data about a part of a population. So perhaps if we're thinking about all of Canada for our census, a sample could be looking specifically at New Brunswickers. Or maybe we're specifically looking at Canadians aged 18 to 24 only in 6 provinces. So that would be a sample. Okay. Then we need to be careful. When we take samples, we want them to be unbiased. So we want it to be very fair. And sometimes we can have biased samples. So a biased sample is one in which the data has been unfairly influenced by the collection process and is not truly representative of the whole population. So when you think about voting for a politician, and maybe in the weeks leading up to the election, you go door to door to ask who they're going to vote. But every time you go to someone's door, you say, oh, by the way, this person is so good. They do A, B, and C for their community. You should really vote for them. Who are you going to vote for? Well, if you're only telling people about one person, your data may be skewed because that might be the only person they know of, so then they're going to vote for them. So we want to make sure that our samples are always fair. Okay, now we're going to look at statistical graphs. So we need to understand the two variables that are under consideration when we have a graph. And so these are our independent and our dependent variables. So an independent variable is one that is controlled. And we say sometimes that it's manipulated. So controlled or manipulated. If we think about our dependent variable, this is the one that changes because of our independent variable. So we would say that this one would be measured. So if we think about this example, we're looking for the total cost of dinner with a group of friends. So if we think about this, well, our independent variable is going to be the number of friends. Because the cost of dinner, which will become our dependent variable, is going to completely depend on how many friends we bring. If I bring 5 friends, it might be $125, but if I bring 10 friends, maybe it's $350. So the big thing here is that my cost of dinner is going to completely depend on my number of friends, which is my independent variable. So that's the one that I'm controlling. So when we think about where these lie on a graph, well, we know that this is my x-axis, and we know that this is my y-axis. So my independent variable is always graphed on my x-axis. So this is where my independent is. And my dependent is always on my y-axis. And there's one exception to this, which we'll talk about in the next slide, of when this changes, but that's the general rule of thumb. So this is a really important visual for you to have, and if you're looking to read through it, and if you want some more information, then page 173 at the bottom is where you'll find this. So we talked about step 4 of the statistical investigation being displaying the data. So these would be ways of displaying data. And this is mainly categorical data. So we have a vertical column graph, a horizontal bar chart, a pie chart, and a segment bar chart. So all of these are representing data. Now I talked about there being an exception for our independent and our dependent variable. So recall that our independent variable goes on our x-axis. This would be my independent, and this would be my dependent on my y-axis. In the case of a horizontal bar chart, that's when things switch. So our dependent actually goes on our x, and our independent would go on our y. And that's just because of the nature of the bar chart being horizontal rather than vertical. So this wraps up section A, for univariate data analysis. Now you're going to go through and do the questions that are posted just below this video on the portal.